Hello students, this is continuation topic for keto, enol, tautomerism and tautomerism part 2. Right, let us take another example for keto, enol, tautomerism. Right, this is very important example to be understand what is keto, enol, tautomerism. Right, here this is carbonyl compounds are. Now it is keto group, C double bond O group is keto group or carbonyl compound. Right, now this is keto form. Keto form. What is the name of this compound according to IUPAC system? 1, 2, 3, 4, 5, 6. Right? So the cyclohexane, right? Because 6 carbons in cyclic structure, that's why cyclohexane. And what is the position of double bond? Second carbon and fourth carbon. That's why you can write 2, 4. How many double bond? 2 double bond. That's why you can write diene. And what is the position of keto? What is the position of keto group? 1 position. That's why 1 on. Suffix for ketone is on. So cyclohex 2, 4 diene 1 on. Now it is keto form, right? And if you seriously observe here this is not a, of course, keto group, the next carbon is called alpha carbon and it is also alpha carbon. But this is not a alpha carbon, sir. I told you already in previous classes. Alpha carbon is must be saturated carbon and sp3 carbon and or carbon to carbon single bond. Now this is not a carbon to carbon single bond. This is a double bond. That's why this is sp2. sp2 hybridized carbon or it is unsaturated carbon. That's why this is only saturated carbon. Why? Because this is carbon to carbon single bond is there. Right? Now this is treated as sp3 carbon. Right? Now this carbon contain 2 hydrogen because carbon must be in tetravalency. 1, 2, 3, 4. Now this is alpha carbon. Yes, this is alpha carbon. Right? Here how many alpha hydrogen we have? 2 alpha hydrogen. So right now I want to use 1 alpha hydrogen. So now when bond break between carbon to hydrogen get positive charge. Now immediately this bond rotate towards this carbon to carbon. And this bond rotate towards oxygen and oxygen get negative charge. Now immediately this positive charge of the hydrogen is migrates towards oxygen. Right. So what happens are here bond and bond. It's already pi bond is there. One new pi bond is appear between carbon to carbon here. Right, carbon. Now this is benzene, sir. Of course we know that benzene is good in aromatic nature and it is extended conjugation is possible, right? And oxygen plus hydrogen to form alcohol. So can you guess what is the name of this compound, sir? Phenol, right? Here you know what phenol is 100%. Now this is enol form, sir, right? It is enol form. Why? Because double bonds are there. That's why suffix for double bond en and alcohol suffix for o. That's why this is enol form. Here enol form is 100%. Right? Here enol form is 100% because the 2 strong regions are there. What are the 2 strong regions here? This is conjugation system, sir. Yes, it is conjugation system or not? Yes, it is conjugation system. Why? Because double bond, single bond, double bond, single bond, double bond and single bond. I told you already in previous classes, double bond, single bond, single bond. That is conjugation system. When it is conjugation system, what happen? It is exhibit resonance. When it is resonance, highly stable. Right? It is highly stable. And it is aromatic in nature. Yes or no? It is extended conjugation. Extended conjugation. That is resonance. That's why it's stable. That's the first reason. And what second is strong reasons? Second one, aromatic nature. Right? This is benzene ring, sir. That's why it is aromatic in nature. So that's why these 2 strong reasons are to explain why enol form is 100% in this example. Right? So I hope you all understand, all of you, in comparatively previous class and this example, previous class of example and this class example, because already I have explained in 2 example in previous classes, that is tautomerism part 2, right? So all this example, what do you understand? The enol form content, the enol form percentage content is increases due to 3 strong reasons are there. What are the 3 strong reasons? One is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. And second one is extended conjugation. Extended conjugation. And third one is aromatic in nature. Right, aromatic reagents. So these three reasons are very, very important, sir. One is intramolecular hydrogen bonding, and second one is extended conjugation, and third one is aromatic in nature. So then, okay, I hope you understand, all of you, why kenol form is more stable than enol form. Due to these reasons are these three reasons are there. So based on this concept, I am going to give increasing order for enol form in various compounds. Right, I am going to give increasing order for enol form in various compounds. So this order is very, 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 very important for competitive exams. Right. First of all, simple aldehydes are. So increasing order for enol form in various compounds. Right, increasing order for enol form in various compounds. Right. First, simple aldehydes are. Simple aldehyde formula, of course, only one aldehyde, that is acetaldehyde. Increasing. Then simple ketone, CH3 C double bond O CH3. Yes, this is simple ketone. And beta keto ester, of course we know that formula, beta keto ester. So CH3 C double bond O CH2 C double bond O C2H5. So this is the formula for beta keto ester. Next, keto ester with pH group. Here pH nothing but benzene ring. So what is the formula? So TH C double bond O CH2 C double bond O C2H5. Right. Increasing. And diol. So what is the formula for diol? Two aldehyde groups are there. Right, two aldehyde groups. Increasing. Diketones. Beta diketone. Right, beta diketones. Can you guess what is the formula for beta diketones? Yes, this is the beta diketone, and we know that because already we are using example to explain what is keto enol tautomerism. Right. Next, ketoaldehyde. What is the formula for ketoaldehyde? CH3 C double bond O CH2 and CHO. Right. This is keto and this is aldehyde. That's why ketoaldehyde. Next. Yes, it is also very well known formula because we are also using this compound for keto enol tautomerism. Yes, what is the name of this compound? Cyclohex 2,4 because 1, 2, 3, 4, 5, 6 2,4 diene. Cyclohex 2,4 diene 1 ol. Last one is highest enol content percent. Nothing but these two are 100%. 2 benzene rings with 2 ketones. Right. So this is the increasing order in various compounds. This is simple aldehyde, and simple butane is always negligible amount in enol form content percentage. That is one less stable of enol form. That's why aldehyde is a very, very lesser. Ketone is also negligible amount. Here 7%. Of course we are used it here. And keto esters. So here among this all these examples or among based on this increasing order, so these two are highest percentage. Yes sir, these two are giving highest percent enol form, I mean more stable enol form and more enol content percentage, because here 2 benzene rings are there, aromatic nature and resonance is possible, and intramolecular hydrogen bonding is also possible. So aromatic nature is possible because benzene rings are there, aromatic nature possible, and external conjugation and intramolecular hydrogen bonding. All three examples, all three rules are possible in this example. That's why it is most stable enol form is possible. That's why highest enol content percent is also possible, right? So based on this order, based on this order, I am going to give one example. Okay. Right, so this is question, sir. Here we have four options, 1 2 3 4 options. So among these four, which one give more enol stable or more enol content percentage? Because they will ask in examination, in exam they will ask any type of question. That's why any kind of question they will ask, right? That's why. So among four options, among these four options, which one give more enol content or which one give more enol form percentage, right? So which one give more enol, more stable enol form or more enol content percentage? Of course, this is simple ketone, sir. I told you already, this is simple ketone because CH3, C double bond O, CH3. That's why it is negligible enol form is possible. And of course it is also negligible. It is negligible enol form or enol content percentage. Of course cyclohexanol also. So it is also giving less stable of enol form. Only 1% of enol content percentage is possible. And of course it is beta keto ester, sir. And also it is also less. It is also less amount. How much? 7% enol content percent is possible. And but this is, sir, already we are used to example to understand what is keto enol tautomerism, right? So this is cyclohex 2,4-diene 1-on. It is giving 100% enol form. Yes or no? It is giving 100% enol form. It is giving 100% enol form, that is phenol. 100% enol form is possible. 100% phenol form is possible. So these type of questions, so they will ask in exams based on this increasing order of enol form in various compounds, right? So I have to understand all of you for this one, keto enol tautomerism. Next one, effect of solvent in keto enol tautomerism. Effect of solvent is also one of the important concepts, sir. Effect of solvent. In keto enol tautomerism. Generally, the effect of solvent is mainly depends on solvent nature. So generally we will see two types of solvents. One is polar solvents and another one is non-polar solvents, right? So this is polar solvent. And the next one is non-polar solvents. Polar solvents is also called protic solvents. Why protic solvents? Because their proton is releases. Non-polar solvent is also called as aprotic solvent. Why? Because no protons are releases here. That's why this is called protic solvent, and it is also called as aprotic solvents because there are no proton here releases. Here proton is releases here. Let us take example. Best example, water and alcohol and acetic acid. So these are example for polar solvents. And non-polar solvent example, hexane, benzene, and last one is toluene. Because the hexane, benzene, toluene here, they are not ready to release protons. That's why they are non-polar solvent or aprotic solvent. So what is the relation to polar solvents and non-polar solvents to keto enol tautomerism? Yes. Keto enol tautomerism is arises with double bonded keto group. Yes or no? Yes or no? It is keto group, right? Nothing but carbonyl compounds, right? When polar solvents with carbonyl compounds, what happens, sir? For example, let us take. I want to take one example. H2O is a better example, right? So here, simple ketone. Now take simple ketone CH3 C double bond O, right? And along with water. So water means H2O, right? H2O structure. Yes, it is bent structure, right? So initially, this electronegative atom of carbonyl compound and this electropositive atom of H2O to form hydrogen bonding. This is called intermolecular hydrogen bonding, not intramolecular hydrogen bonding. It is called intermolecular hydrogen bonding between two molecules. Within the molecule is called as intra. Between the molecule is called as intermolecular hydrogen bonding. This is intermolecular hydrogen bonding. That's why here no enol form is possible. That's why decreasing enol content percentage. So indirectly what you understand, ketone form or ketone content percentage is increases. So then what you understand here, when polar solvents are along with carbonyl compounds of keto form, so to form intermolecular hydrogen bonding, so that's why here enol content or enol form is less stable. That's why enol content percentage will be decreases here. Indirectly ketone form percentage here increases. When the same situation, when hexane or benzene or toluene, because here no protons are released, sir. Here H2O is ready to release. Here H2O is ready to release proton. That's why hydrogen bonding is possible. Here benzene, hexane, toluene, they are not ready to release proton. That's why here no hydrogen bonding is possible, sir. No hydrogen bonding is not possible. Right? No hydrogen bonding is possible. That's why here enol form increases. Right, increasing enol form. That's why enol form is more stable. That's why enol content percentage is increases here. Right. So this is the explanation to effect of solvent in keto enol tautomerism. Right. Once again, what happens are here polar solvent with C double bond O group. What happens are here intermolecular hydrogen bonding is possible. That's why enol form is less stable. That's why enol content percentage decreases. But here when same carbonyl compounds of keto form is along with non-polar solvents, no hydrogen bonding is possible. That's why enol form is more stable. That's why enol content percentage will be increases. Right. So let us take one simple example here. Keto form and enol form. Right. So then if you seriously observe here, keto form is increases in polar solvent, enol form increases in non-polar solvent. That's why here keto form is increase in polar solvent, right? Enol form is increases in non-polar solvents. So this is the shortcut to understand. So what is effect of solvents in carbonyl compounds? Right, so keto form is more in polar solvent, enol form is more in non-polar solvents. So I hope you understand all of you effect of solvents. Right, so let us one last and final important rule for keto enol tautomerism in bicyclic compounds. So this is very, very important, sir. Right, bicyclic compounds. Let us take one example. Right, this is bicyclic compounds, sir. Right, these two are rigid carbons. Right, these two are rigid carbons in bicyclic compound, and this is functional groups are ketone group, carbonyl compounds. Here two types of products are possible. Yes, here this, it is also one of the alpha carbon and it is also one of the alpha carbon. Here two hydrogens are there, here also two hydrogens are there, right? So I want use bridge head of alpha hydrogen, right? Bond here break, immediately this bond rotate towards between these two carbon, this, and immediately this bond rotate towards oxygen and oxygen get negative charge, and this positive charge of the hydrogen is migrate towards oxygen to form double bond appear here, and this is OH. Now this is keto form, sir. Yes, this is keto form, and it is enol form. Here this carbon, especially this carbon to carbon, that's why this carbon is in unsaturated carbon, and carbon to carbon double bond is there, that's why this carbon is in sp2 hybridization, right? And it is sp2 carbon, that's why the structure is planar structure, right? And bond angle is 120 degree. Yes or no? So according to Bridge rule, according to Bridge rule, this is not possible. According to Bridge rule, so this is not possible. Why, sir? Why according to Bridge rule this is not possible? Why, sir? Because only one reason. This enol form does not exist. Why? Here this bridge carbon having double bonded carbon and it is planar, right? And so that's why according to Bridge rule, the bridge carbon in bicyclic compounds cannot be planar. Once again, according to Bridge rule, in bridge carbon, the bridge head carbon in bicyclic compound cannot be planar. That is one of the important rule. And if you remove this alpha hydrogen, this is one reason. And what are the next reason? If you remove this alpha carbon on bridge head, what happens, sir? This bridge will break. Yes, sir, this bridge will break here. So that's why these two reasons are, to explain why enol form is not possible. Yes or no? These two reasons are to explain enol form is not possible in this carbon. Of course, it is possible in this carbon, sir. Yes, this carbon is possible, sir, because this carbon is not a bridge carbon, right? This carbon is not a bridge carbon, sir, right? That's why it's simple. This alpha hydrogen, of course, it is sp3 carbon because saturated carbon and single bonded carbon, right? And this is not a bridge carbon. That's why when bond break here, what happens, sir? This bond rotate towards between these two carbon, and this is get positive charge, and this of course this bond rotate towards oxygen and get negative charge. This hydrogen is migrate towards oxygen to form a double bond appear here, and these two are bridge heads, and this is OH and it is enol. So here enol is more stable compound. That's why, so this enol form is possible in bicyclic compound without other than bridge heads of carbons, right? So that's why, so this is the very, very important rule to understand, for bicyclic compounds. Let us take one example. Previous in JEE Mains 2016 question. What is the question here? First option. Second option. Right. So 1, 2, 3. We have three options are there. Among these, first, second, and third, which one to involve in tautomerism? That is our question. Yes, of course, we know that. Which one will involve in tautomerism, sir? Let us seriously observe here. These two are bridgeheads, right? I told you already. This is carbonyl compound, sir. Keto group. Keto group next carbon is called alpha carbon, sir. Alpha carbon, right? This alpha carbon have two hydrogens are there. Of course, here also two hydrogens. I told you already. These two hydrogens are this 1, 2, 3, 4. Right? These 4 hydrogens are not to involved in. I mean, they're not sufficient to involve in tautomerism. I told you only 2 reasons are. One is breakthrough, and next one is bridge will break. That's why this is not to involved in tautomerism. And second one, so of course this is carbonyl compound, sir. Next, this is one of the bridgehead. Of course, here also 2 hydrogens are there. Right? That's why this carbon of these 2 hydrogens are not to involved in. Not possible to involve in keto-enol tautomerism. Of course, this is also alpha carbon, sir. But this is alpha carbon and sp3 carbon. But here no alpha hydrogens are there, right? No alpha hydrogen. That's right. So it is also not possible to involve in tautomerism. Let us take one example. Yes, this is the carbon, sir. This is carbonyl compound, sir. Keto group. The next, this is the carbon, sir. Of course, this is bridge carbon and of course alpha carbon, but these 2 hydrogens are not sufficient. Not possible to involve in keto-enol tautomerism. Of course, here 2 alpha hydrogens are there, right? This is alpha carbon and sp3 hybridization is possible. That's why these 2 hydrogens should be involved in sufficient. Support to be involved in tautomerism. That's why third option is correct option, right? So this is the way to select which is correct answer in bicyclic compound based on this concept, right? So I hope all of you understand. For this concept for keto-enol tautomerism, I will make next video for another type of tautomerism. Thank you.